So this part of the notes is actually a little bit easier. I mean, the definitions are the definitions, but when we actually work out the problems, they're going to be a little bit easier than having to deal with those radicals. So again, it's going back to imaginary. Now we're also bringing imaginary because that has to do with the roots. So an imaginary number, that I, is the square root of a -1. Or really, it just means there's a negative inside the root, okay? And since we need a number there to hold that place value, we make it a 1 because that doesn't change anything. And so I wrote what these other powers are because we can use those down the road. So I squared means that you're taking this and you're squaring it. And I already talked about how, remember, a square and a square root cancel. So when those cancel, you actually just get a -1. That's why I squared is just the number -1. Okay? Then think of I to the third as being an I squared times an I, because remember there's an automatic 1 there. So 2 I's, 1 more I. Okay, so that's where we come up with I to the third. Well, I squared, if I squared is just the number -1, and I is just the square root of -1, that's where I wrote this. It's just -1 times the square root of -1. That's why, because it's just taking I squared and I and multiplying them, putting them together, okay? Then think of I to the fourth as being I squared times I squared, because there's 2 here and there's 2 here, so that's where the 4 comes from. Well, I squared is -1 times -1. Well, what's -1 times -1? That's just a 1. So that's why I to the fourth changes it to a +1, because it's just like saying -1 from up here times another -1 makes it a +1, okay? Now, we're not going to see that a lot right now, but we will see it before your SOL test, okay? All right, a complex number is a number that has a real part and it has an imaginary part, okay? So the real part is the number without I. The imaginary part is the number with I. An imaginary number is a complex number, so A plus BI, it's the same thing as this, where B doesn't equal 0. All that means is there has to be an I. Okay, for something to be imaginary, then it has to have that I in there. And so that's when it starts changing into an imaginary number. Okay? And then conjugates are just like conjugates we did with the radicals, the square roots. It's a complex number, so it's got a real part and an imaginary part, but one is adding and the other is subtracting, okay? And because I represents a root, then just like before, we have to get rid of it. Hold on.